Hi everyone, welcome back to my channel. In this video, I'll be solving this Geeks problem called BST, binary search tree to greater sum tree. So we are given with the root node of the binary tree. We need to transform it to greater sum tree. I will explain how we can transform a binary search tree to greater sum tree. Let me copy these images. So this is the input given, and this is the output. Let me resize these images to a smaller. So these are the inputs and outputs given. So here binary search tree, we know that property of the binary search tree is every node which is greater than the root node will be added to the right side, and every node which is less than that the root node is added to left side. So in order to calculate the sum of the nodes which are greater than that particular node, simply we can iterate over the right side. So here we will first iterate through the right, and then we will calculate the sum. So at first we will be at this root node, and then if there is any right node present for that root node, then we need to go for that, first visit that right node. If there is any root node, then again we need to go for right node. If you observe carefully, for the node 40 we don't have any right node. We need to add it to sum. So in the sum, 40 will be added, and our next step is we need to remove that particular node with sum, and then what we need to do is sum minus data in that node. Nothing but 40 will be replaced with 0, and then we need to iterate to the left node. After that, in the left node we have 35, our sum is 40. We need to add 35 to the 40, nothing but we'll get 75 minus, we need to subtract that 35, so we'll get 40 here, and then we'll backtrack, and then backtrack. We got 29 here, we need to add it to sum. So 40 plus 35 plus 29, how much do we get? 75, 85, 95, 104. So our sum will become 104, and we need to replace with sum minus that particular node. Nothing but we will get 75 here, and then we will backtrack. We got 11. We need to add it to sum. 104 plus 11 will give you 114, 115, and we need to subtract. Wait, we made some mistake. Hmm, 40 plus 35 plus 29, 75, 85, 104. I think we forgot to add this 15 here. Yes. So after that we will visit this left node, and we will add it to sum. Nothing but we will get, sorry, this 11 won't be there. 104 plus 5, 119. 119 minus 15 will be added here. Nothing but we will get 104 in the node 15, and then backtrack. We will be here. Our current running sum is 119. 119 plus 11 gives you 120, 130, and we need to replace this 11 node with 130 minus 11, nothing but 119. So here we will get 119. After visiting all the right node, we need to traverse to left. So here we are here. If there is any right node, then we need to first visit that right node. So 111, our current running is sum is 130. So 130 plus 7 will be our current sum now. We need to replace with 137 minus 7, nothing but we'll get 130 here. uh, after visiting right now we need to backtrack. We got to let add we need to add it to current running sum, nothing but 139 minus 2. We need to replace it with minus 2, nothing but 137. And we got our last node. Our current running sum is 139 plus 1, we will get 140. And if we replace with 140 minus 1, we will get 139. So nothing but the output which we got. So our traversing technique is, at first we need to visit root dot right. I mean we need to traverse for the root dot right. We need to maintain a running sum. We need to add the data to sum, and we need to replace the node with sum minus root dot data, and we need to traverse for the root dot left. Let me implement Python solution for this. At first I will declare a variable sum in order to maintain the current running sum, and I will take a function called traverse. If you observe carefully here, we are traversing in a reverse inorder traversal. So base condition for this recursion is root. If there is any root exists, then we need to traverse, otherwise we will get back, I mean we will return from that function. At first we need to traverse over the root dot right, and then we need to add the current data to the sum variable, and we need to replace the data with sum minus root dot data. After that we need to traverse left side. uh, in the main function we need to call the function called traverse by sending the root as a parameter, and at last we need to return the root of the modified binary tree. So if I compile this, we will get an error. This is why, because the function traverse is unable to find the variable called sum. For that we need to declare that sum does not belongs to current function, it belongs to outside function, nothing but it belongs to this transform tree function. So there is a keyword in Python to tell this function. It's called non-local answer, I mean sum. So what this will do is, it will tell the current function that the variable sum does not belongs to current function, it belongs to outer function. If we compile and run, let's check what happens. So we are passing the sample test cases. Let me submit and check. So it's passing all the test cases. Thanks for watching.